Deepseek AI has launched a new version of V3. This is an incremental version, V3.03.24. It's already the #1 trending model in Hugging Face. Now, if you look at their official changelog, they say that this particular model, DeepSeek Chat, also the model has been upgraded to DeepSeek V3.03.24. It has enhanced reasoning capabilities, significant improvements in benchmark performance. So they are saying a 5.3 increase in performance in MMLU-Pro, plus 9.3 on GPQA benchmark, plus 19.8 on AIME benchmark, and plus 10 on LiveCode benchmarks. This is optimized for front-end web development, improved accuracy in code generation, more aesthetically pleasing web pages and game front ends. It has upgraded Chinese writing proficiency. It has feature enhancements like improved multi-turn interactive rewriting, optimized translation quality and letter writing, improved Chinese search capabilities, and function calling improvements. So this model is around 685 billion parameters, right? So this is a huge model, and it has already been deployed on DeepSeek Chat. So what I did over here is that I gave an image input like this, right? The DeepSeek AI, the landing page, and I asked it to actually, generate a front end that will look like the attached image. So here it has generated the front end code for DeepSeek landing page, right? So we can actually run this code. Let's run this code, and this is how it looks like, right? So this is the user interface created by this particular code. You can judge for yourself how good it is, but it is supposed to have improved for front-end coding. Okay. Now, if you look at some of the benchmarks or evaluations, I found a Reddit post which says that, the misguided attention, that particular benchmark, where it looks like you have these problems like, where reasoning is needed and where LLMs kind of struggle, right? So on those problems, V3.03.24 is almost ahead of Sonnet 3.7, non-thinking, right? So misguided attention is a collection of prompts to challenge the reasoning abilities of large language models in the presence of misguiding information. Over here, if you look at the performance of this particular model, the DeepSeek V3, this incremental update V3.03.24, it's actually increased almost double, right? And it is almost, it beats Claude 3.7 Sonnet non-thinking. Okay. So other models over here are all thinking models, like Claude 3.7 thinking, DeepSeek R1, QWQ 32 billion parameter. This is not really a thinking model, but it has been trained with reinforcement learning to improve thinking. Okay, so this model is comparable over there, right? And here are benchmarks, again comparing it with various things. So real world coding benchmark normalized on a this thing scale. So if you look at this particular benchmark also, where do we see DeepSeek over here? Let's see where it is present. DeepSeek V3 is present over here. DeepSeek V3.24 is present over here. It compares well with Claude 3.5 Sonnet or Claude 3.7 Sonnet thinking. Claude 3.7 Sonnet thinking is still ahead, but it is still good, right? So this is a very good incremental update. Maybe we'll try out some other use cases over here, right? So maybe we'll try out a misguided attention reasoning problem. Okay, so let's open misguided attention. And let's look at some of the prompts over here, right? So for example, we can try out the no trolley problem, basically the standard no trolley problem, and I think it should be able to do it. This shouldn't be much of an issue. I'm expecting it to say that this is a standard runaway trolley problem, and classic problem and thought experiment, and you have the utilitarian approach. There is no standard answer for this. Okay, so basically the trolley problem is a runway trolley is hurting down a track towards 5 dead people. You stand next to a lever that can drive the trolley onto another track where 1 living person is tied up. Do you pull the lever? Right. So this is an ethical dilemma kind of question. It is standard done to death question. So let's try out something else over here. Let's go to misguided attention and let's try something else over here. Okay. Yeah. Let's try out this. There is a man, a sheep, and goat with a space for 1 human and 1 animal on one side of a river. How do the men and sheep get to the other side of the river? Let's try out this. Okay, I'll understand information. Understanding the problem, we have the following elements: character entities, a man, sheep, boat specification. The boat can carry 1 human and 1 animal. If cannot carry, okay. Amazing. Analyzing possible moves. It tries to, let's see what is the final solution. Constraints, okay, there is no constraints. Verifying for hidden constraints. Okay. Potential misinterpretation. One being at a time, then the solution would be, okay, the man takes the sheep in the boat with him from side A to side B in a single trip. Actually, that's the answer. So it is given a proper answer over here. Now let's try one more coding problem. create 3D visualization. Solar system. Let's see what happens. Okay, here is a conceptual design. While I can create and I can describe how it will look. It's giving me some kind of text over here. Okay, it's given some kind of an HTML. Where is the code? Okay, what is this? Nothing. Let's see. I don't think this is what I expected. Let me be a little bit more clear and say that create a 3JS solar system visualization. Let's wait for it to generate the code. Now we should be able to run this and see it. So it has actually generated this 3JS visualization. It has generated the code over here based on the single prompt, create a 3JS solar system visualization. And when I run it, it looks like this. Here are all your planets revolving around the sun. And if you look at some of the revolutions are slow, for example, like Saturn and the other one, because, of the fact that they're farther away from the sun, right? Oh, the Saturn is going out. I'm not sure what's happening over here. So let me restart it. Okay. So this is the kind of planet revolutions around the sun. Maybe some amount of changes needs to be done over here. Maybe this is right. Let's toggle the orbits. Let's see. Okay, it comes up like this. Interesting. But I'm not sure why Saturn is going out over here. It's going just far, far, far. Okay. Maybe still some amount of fine-tuning or the other things are required over here in the prompts to get a proper visualization. Reset view. Oh, Saturn is coming back again as a big one. Okay, so whatever it is, right? Then we can look at another coding problem or a mathematical problem. Let's open a math benchmark. Math QA Hugging Face dataset. Okay, meta math QA. Do we have a question over here? Okay, we do have original question. And we do have an answer. Okay, let's look at what is this question. Okay, let's copy this question. And let's try this. Gracie and Joe are choosing numbers on the complex plane. Joe chooses the point $1 plus $2i. Gracie chooses $-1 plus $i. How far apart are Gracie and Joe's points? So this is about computing distance in complex plane. So let's see what is the answer. Okay, the response is the distance between 2 points in the complex plane is given by the formula. In case of this, the answer is square root of 5. Let's see what comes over here. Okay, so it is giving the distance formula. Over here, distance between 2 points in a plane is given by this. Let's assign the points. Okay, first calculate the difference in x coordinates. Now squaring the differences and this thing. Okay, it is given the proper answer over here. Okay, square root of 5 distance units. Right, so this was a maths problem. We can try a Python coding problem as well. Let me try create a snake game using Python. Generating the code. So it has created the code over here and I could copy paste it over here and try it out. So basically I have copied the code over here and here is your snake game and I can actually play over here. If you see this, right? So it is able to create the snake game. Okay. Wow. I'm very bad at playing this game. But as you can see, it has created the code over here, right? So you can try out different things over here. There were a couple of use cases which I have tried. So this model definitely seems to be improvement over Deepseek V3. It is evident from the benchmarks as well as when you try it out over here, right? Even though this is limited testing, and the best part is that this model is actually open source. So if you have the infrastructure, you can actually run this model locally, right? And the other thing is that maybe quantized version of this model will start. People will start creating quantized versions of this model. So we should have a good chat model with this. Hope this video is useful. See you in another video.